Okay, we are going to talk about something sci-fi adjacent today. We're going to go into a little bit more physics detail about the speed of light and why it matters. And we're doing this because sometimes it's just good to have a bit of a refresher about some of these topics that we love to explore through science fiction. And we kind of need to be reminded as to why they exist. Like, why is there a speed limit and why do we write sci-fi stories then that have to break it?
Scotty, I can't change the laws of physics.
So one of the biggest problems that I think that we have when we talk about the speed of light is that it's really, really hard to kind of wrap your head around how fast it really is. We view it as being really slow, but it's not. It's incredibly fast. Now, I can't blame anyone for this because a number is a number is a number, right? It's just, it doesn't mean anything, not to us in our daily lives. I can tell you that the speed of light is 299,792,458 meters per second, but our brains, like, they're not really built to process what that actually looks like. It's just a big number. It might as well be completely abstract, but it's not abstract. It is a very real value that we can measure, and it helps to structure our universe. It's not just the speed of light. It's the speed of information. It's the fastest speed that anything, anywhere in the universe can transmit cause and effect. And that's why it matters, because it's not just about like beams of light zipping through space. It's about the limit on how fast anything can happen. But when we talk about space travel or like science fiction or even some real scientific theories, we kind of get tripped up by this idea. And we've all seen ships in sci-fi jump to warp speed or, you know, fold space-time, pop across the galaxy instantly. The more we see that in stories or in pop culture, the more it warps how we actually think about what's possible. But the thing that I always kind of come back to, and this is really, I guess, the main heart or the point of why I wanted to make this video in the first place, is that understanding the rules of the universe doesn't actually make it less interesting. If anything, it makes it way more interesting. Like, come on, the fact that there is a speed limit at all, that should blow your freaking mind. So let's talk speed of light. But before we get into it, if you're enjoying what I'm doing here, then please do like, subscribe. You can check out my Patreon series if you want. You can check me out on some other outlets, media channels. What are they called? Apps. One day she will be a good YouTuber. I'm still working on being a good scientist right now, you guys. I can't do both at the same time. Okay, let's move swiftly along, but not as swift as the speed of light. Come on, that was beautiful transition. God. All right, how fast is it really? Let's start there. So the speed of light in a vacuum is, as I said, 299,792,458 meters per second. But what does that actually mean? Well, I have a thing that we can think about, right? So if we think about the size of the Earth, the circumference of the planet at the equator, it's about 40,075 kilometers, right? Now, how long do you think it takes for a photon of light traveling at the speed of light to make it all the way around the Earth? I'm going to give you a second to take a guess. You can write in the comments if you want. Okay, you got it, you got it, you got it? It takes about 0.1337 seconds. That means that a photon can circle the entire planet 7 times in 1 second. 7 laps of the Earth every second. Do you even know how many have actually done it since we started this video, or how many laps it has done since we started this video? I was thinking about doing a counter. I should have done that. Hey, maybe there'll be a counter on the screen. Who knows? Who knows what future Abby's going to do in the edit? Okay. Now we can talk about sci-fi for a second because I want to come to something in the three-body problem, because this comes up a lot when I make videos about it. People always ask me this question. It's specifically centered around the idea that the sophons, the tiny little particles that can interfere with scientific experiments by moving at almost light speed. A lot of people think that the idea that they could do all this, that they could interfere with the experiments around around the world, run a clock down on a scientist's eyeball, that's just a really far-fetched idea. How could they possibly have the time to do all of that? Well, if you can accelerate a particle to near light speed, you can absolutely do damage. If a proton can lap the Earth 7 times per second, imagine what it could do just crossing the space of your eyeball. There is more than enough time for it to interfere with, say, like 2 experiments on either side of the world and still make it back to count down the next second. This is the speed that we are dealing with. So, if light is that fast, then why do we think we need to go faster? It's scale, of course. Here on Earth, the speed of light is insanely fast. It's incomprehensible, uncomprehensible. Which way is the right way to say that? We cannot comprehend it. We say it that way. Inconceivable.
Inconceivable! You keep using that word. I don't think it means what you think it means.
But out there, in the universe, the speed of light, it's slow. When we are dealing with galaxies, with stars, with cosmic distances, even photons, they can take thousands, millions, billions of years to travel between them. It's not because the speed of light is slow. It's because the universe is freaking enormous. But let's get to the crux of the matter. Why can't we just go faster? Why do we even have a cosmic speed limit at all? This is usually where the conversation might kind of derail a little bit, because I think we focus too much, like I said, on the number itself instead of what it represents. Because the speed of light, it's not just how fast light moves. We refer to it as the speed of light, but what we mean is it's the speed limit for how fast information can move through space-time. So I guess the next question is, well, what is information? What do we mean by that? Now, when we talk about information in physics, we're not talking about Wikipedia or a book or social media posts. That's not the kind of information we mean. We're talking about the fundamental structure of reality. Sounds a bit dramatic, I think. Now, every single object in the universe contains information. It's the arrangement of particles. It's the structure of atoms. It's the specific combination of molecules that make you, you, and make me, me. Now, at its core, information is the difference between things. In physics, information is carried by particles. A photon has energy. It has wavelength, it has frequency, direction, and all of that is information. When photons from the sun hit your eyes, they're carrying the story of where they came from and how they got here. So why can't information just move infinitely fast? Like, what would actually happen if there were no limit? Well, really think about it. Let's imagine something here. Say a star explodes on the far side of the galaxy. If information could travel instantly, you wouldn't eventually see the explosion. You would see it immediately. But you would also see everything else all at once. Every star, every signal, every moment. It wouldn't matter when or where something happened. The signal from that event would arrive at every point in the universe immediately. There would be no separation between moments. You see, the reason that the universe works the way it does, the reasons that events can unfold, that we can see one star explode and then another star explode at a later time, is because there is a limit on how fast that information can travel or how long it takes for it to reach us. The cosmic speed limit is what allows events to happen in an order. And that limit is what gives us structure. That's what gives us time, basically. So when physicists talk about the speed of light, what we're really talking about here is the speed of causality, the maximum rate at which information, any information, can move through space-time. The fastest that a cause can produce an effect. Now, I hear you already. I know where you're going with this. You're already shouting at the screen, what about the expanding universe? Or what about quantum entanglement, Abby? Huh? Well, I have answers. Because people do always ask this. Whenever I make videos about the speed of light, the two main questions will be, but wait, isn't the universe expanding faster than light? Or doesn't quantum entanglement bypass the speed limit? They're really good questions, and I completely understand why people ask them. So let me explain. Starting with the first one. The speed limit applies to objects moving through space-time, right? We've said it applies to signals, to information that is sent across space. But when we say that the universe is expanding faster than light, what we mean is that space itself is stretching. Galaxies aren't moving through space. The space between them is growing. Now that's very different from sending a message or from information traveling. So what about the second one, quantum entanglement? Quantum entanglement is a phenomenon where two particles become linked so that the state of one seems to instantly influence the state of the other, even across vast distances. Now, it can seem like this is a form of instant communication, but it's not. No actual signal is sent. In entanglement, the outcome of one measurement correlates with the other. But you can't control it. You can't use entanglement to send a message. You can't choose what result you're going to get, so you can't encode any information into it. The only way to confirm what's happening at the other end for the second particle is to still use classical communication to, discuss what the results were. And that signal obeys the speed limit of the universe. So despite how weird and wonderful quantum physics gets, causality remains intact because no information is being transmitted. The speed limit isn't broken. So, we know that there is a speed limit. We know that we need the speed limit in order for events to happen in sequence or in an order that we can make sense of. We know that there are certain situations where things can appear to be moving faster than this speed limit, but they don't actually connect to sending information. So the question really that we're left with now is, why this speed? Like, why not some other number? The truth? We don't know. We just don't know, right? What we do know is that this number, this value, the speed of light or causality information, this links to a whole network of other constants that structure the universe. Now, there's something in physics called the fine structure constant, right? It's a weird little number. Its value is 1 over 137, and it shows up in a lot of places, okay? It determines how strongly light and matter interact, and it connects some of the most important constants in the universe. We have the speed of light, Planck's constant, and the electric charge of the electron. This value, it's a dimensionless value. This means that it doesn't actually depend on our man-made units. Like the speed of light is meters per second. The fine structure constant, there's no units on it. It's just a number. So what this means is that we could change the definition of a meter, right? Or we could redefine how long a second is. This number will stay the same. This is because of the relationship that it has with these other constants. But why this number is what it is, we don't know. We don't know why it has the value that it does. It could, in theory, be anything. But it turns out that it's exactly what it needs to be for a universe like ours to exist. And this is where I'm going to invoke something that makes people upset. The anthropic principle. Now, there are different versions of it, but like at its most basic, the anthropic principle is saying, we observe the universe the way it is because if it were different, we wouldn't be here to observe it. So maybe the universe isn't fine-tuned for us. We just happened to evolve from one because it has the right conditions. Now that can sound like circular logic, and people do tend to get quite upset with me when I bring up the anthropic principle, but it's not trying to explain why the universe exists. It's just trying to explain why we see this version of it. You see, if the speed of light or the fine structure constant or the strength of gravity were just slightly different values, atoms wouldn't form, stars wouldn't burn, chemistry wouldn't work, and life, as far as we understand it, would not be possible. Now, we could take this further and we could link this to the idea of a multiverse in a cosmological sense. Maybe there is a vast set of other bubble universes out there stretched out beyond what we can see of our observable universe. And each one of them may have different physical laws. And if that is true, then of course we find ourselves in the one where the laws allow for our kind of life. Because where else would we be? It's not about saying that there's intelligent design. It's not saying that the universe was built for us. It's just selection bias on a scale of the entire cosmos. And it also doesn't mean that this couldn't happen again. You see, if the multiverse idea is true, the cosmological multiverse, then maybe there are other universes with different rules, some lifeless, some chaotic, maybe some with entirely different kinds of observers asking totally different questions. But from what we can see, this universe, like our one, works the way it does because of these constants. And the speed of light is part of that structure. Now, if the cosmic speed limit was infinite, if there were no limit and information could just travel instantly, there'd be no causality, there would be no sequence of events, there would be no way for complexity to build up. And without change over time, there is no life. A universe where everything happens at once is a universe where nothing can happen. So maybe the speed of light isn't just a number. Maybe it's the thing that makes a universe happen. Maybe there's a reason the speed of light is what it is, and it's simply just because it had to be, or because it just is. Now, that may not be a satisfying answer for you. I get it. People have complained to me this before, saying, oh, it's not an answer. But not everything has to have a reason. Certainly not on a universal scale. It doesn't owe you anything. There's no requirement for there to be a reason that makes sense to us. Because the final truth is that without that limit, the universe might exist, but we wouldn't be here to ask the question, why? Now, hopefully, some of you are thinking, sure, that makes sense. But I also know from experience that some of you think that this is just a total cop-out, or that it's not a real answer. But I don't know how else to frame this so that people really grasp just how inconsequential we are on the scale of the universe. Think about it this way, right? Modern physics has only existed for 100 years. We are babies in the universe learning to walk. What we have learned is incredible. What we could learn, who freaking knows? But even with all of that, there is still nothing that says that there must be a satisfying answer. There is nothing about the structure of our universe that says that it has to make sense to the brains of one species floating on a rock in a tiny section of a medium-sized galaxy in a vast expanse of billions of galaxies in a universe of an unknowable size. So it's the best answer you're going to get from me, I'm afraid. And it's the best answer you're likely going to get from the universe. For now, anyway. Thanks for watching. I hope you're not having an existential crisis right now. If there's any other confusing topics in science, things that you see in sci-fi or in the news or just like every day around you, then let me know and I will do my very best to break it down. But thanks for hanging out with me. But yeah, I want to know what you think. Do you think it's a cop-out? Do you think the anthropic principle is a good enough reason? Like, is it satisfying enough to say like, well, sure, you know, if it wasn't that way, we wouldn't be here. So it just happens that they're the values that allowed for life to exist. Doesn't necessarily mean that it had to be intentional. I'm satisfied with it. I'm fully satisfied with it. But how do you feel about it? Yeah, so if you enjoyed this, the like, subscribe things, stuff. Guys, someday I'll finish my PhD and I will become a competent YouTuber with a proper outro. But for now, I ain't got one for you. So, goodbye.